In this video, we're going to create a token on the Stellar network, which is airdropped to users of the decentralized exchange, SDEX. We're first going to create a script which goes out and collect user addresses for people that are interacting with Stellar's decentralized exchange. We're then going to condense that list of addresses using a Merkle tree. This is going to allow us to verify the data on chain. We're only storing a root hash within the smart contract, making it a very efficient way to verify off-chain data on chain. We're going to build this into a claim function within a token contract, so users can go in and claim their free tokens, and this will all be presented in a nice front-end Web3 UI. Before we get started, let me just talk a little bit about how Merkle trees work. So you've got this list of user addresses, and just say that list could be really big. It could be 100,000 addresses that are eligible for your airdrop. Now, if you wanted to store that on chain, it'd be costly. You'd have to store all that kind of data in a decentralized manner. So what we can do is we can pre-compute that down to a root hash. This means that we're taking all that data and we're generating these proofs. So we run a mathematical formula on addresses and they produce these leaves within the tree. And then the user can pass through their address with the proofs and it can verify that that proof was generated to this root address. In practice, what that means is when the user goes onto the web application, they'll connect their wallet, which will provide the address, so we know what address they're coming through. If they're eligible for the airdrop, the actual front end will deliver the proofs. This can be like a series of hashes. These are then constructed into a blockchain transaction that's passed through to the smart contract claim function, which is where it's verified and it's signed off that that user has claimed his airdrop and he's taken the tokens. Now, obviously, Stellar is a very performance-focused blockchain with low transaction costs, but whenever you use a decentralized computing environment, there's limits on what you can do and the amount of data you can store on chain, and that's where Merkle trees come to the rescue. So the code for this is open source on GitHub. There's a link to that and the full tutorial in the description. So we've got 4 directories here within the repository. We've got build list, which is the code which is going to go out and collect the users from the decentralized exchange. Probably if you're doing this for yourself, you want to kind of create your own custom script to decide who gets the tokens. There's then the front end user interface, the Merkle tree, which you're going to use to condense the data down to a Merkle root and proofs, and the token itself, which is going to be the Soroban smart contracts. Let's go into build list first. If we go into source main.rs, let's copy this into VS Code so you can see it. You can see you've got a fairly standard Rust script here, which is using the Horizon testnet server to go out and check for trades on the Stellar decentralized exchange. We're then putting all of them into a vector or an array, and we're going to take out any duplicates, and we're going to set an amount to this number here, which including the 7 decimals is 100 tokens. Now, there's an opportunity here. If you wanted different users to get different amounts, you could change this token amount for individual users just fine, do that in a programmatic way just to output the file. Finally, we're going to write all this to a nice little JSON file called sdextraders.json. And you can see an example of that here. So we've got the address, the amount for each user. And these are the addresses of the users who have either provided liquidity or interacted with the Stellar SDEX. Now let's put all that information into a Merkle tree. So we go into source. Got 2 files here, lib and main. The library file contains functions to create a new Merkle tree, get the root, get the proofs, and merge different Merkle trees. There's a SHA-256 hashing algorithm and a verification function there. If we go into main, we can see how this is used. So we're importing some standard Rust features in the Merkle tree library. We then got this make receiver function, which takes the address, amount, and it converts that into smart contract values. And we've got the main file for the script. We're going to check the file exists. And this is very over-engineered because I had a bunch of issues with the encoding of the file. I was outputting it using the command line, so it wasn't saving it as UTF-8, which meant I couldn't import it. If we scroll down, we can see once we've got that file open, we're going to iterate through it, use that make receiver function, map them all, and then create a new Merkle tree here. We then use the tree.root function here to print out the root of the Merkle tree. This is going to be like a long hash string. And then we're going to iterate over all the serialized receivers and create a map of the proofs. And we're going to output that to the proofs file name. So let's go ahead and run this. I'm going to use a Windows subsystem for Linux here. So I'm going to cd into the Merkle directory. I'm going to go cargo run. I'm going to provide a couple of values here. I'm going to provide the sdextraders.json, and I'm going to provide an output file for the proofs. And there we go. You can see we've got this root hash here, which we're going to need in the smart contract. And we also, if you go into the directory, got a list of proofs as JSON data. So when each user is going to actually claim the airdrop, they're going to need their address, which they'll already have, but they're also going to need these proofs, and these are going to have to be delivered via the front end. Now let's have a look at the token contract itself. So this is based on OpenZeppelin's code. We're importing the Stellar Fungible token library from OpenZeppelin. And we've got this Stellar Merkle distributor. This is a new package that isn't audited yet, so it's kind of in development currently. It's probably still going through the auditing process. Merkle distributor here. Probably by the time you're watching this video, version 0.3 of the OpenZeppelin contract libraries will be released, and this will be audited, etc., and it'll be safe to use. But check in the GitHub repository just to make sure. So if we scroll down, we've got a pretty standard token contract here. A few differences is, one, we're passing in the Merkle root into that constructor argument. So when we're deploying the contract, we're passing in the Merkle root, which we just generated. And we've got call an airdrop token as a ticker symbol here. And we're setting up this distribution using the Merkle root. Got a little helper function here to check if the airdrop's been claimed or not. Then we've got this public claim function. So the user is going to pass in the index, the receiver, the amount they want to claim, and the proof. We're checking the receiver is who they say they are, and then we're checking that the data and the proof that they provided matches what we have in that Merkle root. If all that verifies, then it sets a data storage to claimed, and we can mint them their tokens. So there's no actual tokens that are minted straight away with this contract. It's up to users to claim them over time, so it would only increase the total supply once users have claimed their airdrop. We can copy this Merkle root, and if we clear this, so I can move into the token directory and run cargo build target wasm32 v1-none with the release flag. Let's run that, and we'll get an optimized wasm build. So this is going to give us a wasm file, WebAssembly file. From there, I can run Stellar contract deploy. I can use that WebAssembly file, airdrop.wasm, using my source account as James, network set to testnet, and then we've got these two hyphens here to kind of pass constructed values across. I'm going to pass the Merkle root, which is this number here. Let's go ahead and deploy that to the network. Fantastic, so we've got a contract deployed. We can go have a look at this in the block explorer. What we should see if we go into the interface is all the pretty standard token functions along with claimed and is claimed. Final thing to do is set up a front end. I'm using React and Vite for this. It's based off some code by Peter Lieu, which is open source on GitHub as well. And what I'll do is I'll demo this first, and then we can go ahead and look at the interesting parts in the source code. So this is our wallet. I'm going to sign into my Freighter wallet. And we're on testnet here already, but if not, just make sure that's checked as testnet. I changed one of the addresses in the original SDEX users file to my address so I can demo this. Let's connect the wallet, and it says you're eligible to claim tokens. Fantastic. Let's claim some tokens. Approve and continue. Also be careful with what you're signing. There's a whole bunch of scams and fraud and wallet drainers that kind of use token airdrops as a kind of way to get people to kind of sign malicious transactions. And we've got our 100 tokens. And if we open this up in Stellar Expert, you can see we raised the mint event for 100 of our airdrop token. Hope you enjoyed this video. If you want to learn more about creating tokens and other digital assets on the Stellar network, then there's a full list of resources and a tutorial in the description. Thank you for watching.